All right, so we're finishing up the first unit, which is in chapter 1, and we're actually going to take just like a day or two break until we go into the next unit. So we're just going to look at something called variation, and it's actually in chapter 8 of your textbook. So last year, or not last year, but in Algebra 1, you talked about direct variation, where things directly related, and the example I always used was like the amount of gallons of gas you buy at a gas station and how much you pay. So if you get 0, you pay 0. But if you get 5 gallons, you pay, I don't know, 15 bucks or more. And then if you get 10 gallons, you'll pay 30 bucks. And so as one increases, the other increases as well. And so that's direct variation. And so just as a review over here to this side, direct variation, okay, is as one, or we'll say as x, because usually that's what we use, as x increases, y increases. Okay, so that's just kind of a review of something you did a long time ago, but we're going to have to relate direct and inverse. But now we're going to go into inverse and then also joint variation, which is a build on top of direct. So inverse variation, it's just like the inverse property, where if direct is as one goes up and the other goes up, the inverse is as the x value increases or goes up, the y value actually will decrease or get smaller. Okay, but formally it's written like this. Two variables, oh, here we are. Two variables, x and y, show inverse variation. Let me move that out of my way. Inverse variation if they are related. Oh, let me spell that right. If they are related, y equals, let me see, what do they use? They use the variable a over x. Sometimes you'll see a k. I know, like when I used to do it with my Algebra 1 students, I used m because it was like slope. But so this is the inverse of direct, because direct was y equals a times x. Okay, so if direct was that they multiply, as you put this in, it's going to multiply, so it's going to increase. This one's the reverse, or the inverse. Okay? And also you can think of it as, if this one's multiplying, that one's dividing. They're inverses. This one's the whole number, that one's the fraction, like our inverse property. Okay? So that is, and again, let me add this a little bit to it. As x increases, y decreases in this case. Okay? And the example I use a lot is like mowing the lawn. If it takes one person 2 hours to mow my lawn, well, if I increase the amount of people, like now I ask 2 people to mow my lawn, what it does is it divides the time. It actually, instead of one person taking 2 hours, 2 people will just take 1 hour. So as the amount of people increases that mow my lawn, it gets divided into smaller sections, so it takes less time, so the time will come down. Okay? And I feel like that's a really good way to understand, as one increases, the other will decrease. Okay? Alright, so the constant of variation is this a that we've written up here. So the constant of variation says this, or its definition is this. The non-zero constant a, again, you might see the variable k, you might see the variable m, and it's non-zero, so a can't be 0. It has to be a number. There has to be a relationship in a variation equation. Okay, so this is our constant, and this is our constant. It's the relationship between what's going on between X and Y. And like in buying gas, the gas price would be the constant. It doesn't change. It's the same amount whether I buy 2 gallons of gas or whether I buy 15 gallons of gas. Okay. For the inverse, if it was like mowing the lawn, the amount of time it took, that's what our constant would be, because you would just be dividing the time by the people. Okay? All right, and then joint variation just builds on top of direct. So the joint variation definition is when a quantity varies directly so it does relate to direct variation with the product of 2 or more quantities. Okay, and we'll be practicing joint variation. It just means that instead of A times X, we're going to be multiplying a few more things. That's all it means. It's still direct, but there's multiple things involved rather than just X and Y. That's all that's saying. Okay? So here are our definitions, and then we're going to look at the different ways we can write the formulas, and then what to use and how to solve. So, alright, so let's look at the bottom of the page. Alright, so we already said that the formula for inverse variation is y equals a over x. Okay, so it's a division problem instead of a multiplication problem. The number that you're given for x divides the numerator, so this becomes smaller and smaller, it becomes a fraction, okay? The constant a is the constant of variation, and y is said to vary inversely. That's a lot of times the phrase you would hear. Vary inversely with x, okay? Whereas back like in Algebra 1, you heard the phrase varies directly. Okay, we're going to start using varies inversely, and then we're also going to start hearing varies jointly. So that way you just kind of know which formula to use. Now, I really like the next part because you can see the formulas, the equations for direct and inverse in different ways. So we want to look closely at how the different equations could be written, because then that's how we're going to know what to do. So let's look at that bottom section. Alright, so tell whether x and y show direct, inverse, or neither. Okay? So we're given this equation, y over 9 equals x. Well, the thing is let's put it in terms of y. Alright, let's get it to say y equals. That way we can decide if it's y equals ax, which is direct, or y equals a over x, which is inverse. Okay, so this is direct variation. And this one would be our inverse. But they both say y. Okay, so in order to get this to say y, you need to multiply the 9 over here. So x times 9 is the same thing as 9x. And if you notice, this now matches a direct equation. So this is a direct variation. Okay? And then this one, this is a very common way that you could see something written. It actually could help us down the road when we're trying to find some relationships and find some constants, but it's not solved for y. So if we want to solve for y, we want to get rid of the x by dividing it to the other side. Okay? And maybe instead of doing that, I'll say divide both sides by x. So the x goes away, we have y equals 3 divided by x. And if you notice, now it looks like the inverse variation. A is 3 and x is in the denominator, so this is an inverse variation. So even though they didn't originally, you saw fractions or you didn't see fractions, because they can be written differently, if you always put them in terms of y, you'll recognize them better. Some of these might actually be easier for other things we want to do, but for recognizing the y equals helps us know which one is which. So we can do the same thing at the bottom. All right, so we're just deciding which one do we have. I still have this off to the side so we can relate it. All right, this says y equals x plus 2. Well, if you notice, neither one of these are adding anything. That's one specific part of the definition. Neither one adds or subtracts anything ever. It's always just this relationship with x. So, since this is adding something, then it is neither. That makes it neither. Okay? This one, again, we need in terms of y. So let's divide both sides by the x. And if you notice, we'll get y equals 5 over x. So we know that now that we have this fraction, okay, that this is inverse. And this one, again, we need y equals. So I want to multiply the 2.6 over to the other side. I'll get y equals 2.6x. Now we can see, oh, well, that's direct. 2.6 is a, and then there's our x. So this is a direct variation. Okay? Now, some of these others, like this relationship is going to help us down the road. This one we might not see quite as much. But so it is nice to recognize that when you have something like this, it also is inverse. They're just written differently. And then we'll talk about that more on the next page of what we're going to be practicing. Okay?